Vsepr molecular geometry practice. What you're going to be doing in this worksheet and the other page just like it is you're going to do the same thing as you did in the last packet, where you make a covalent bond using the atoms that it tells you are in the molecule right here. After you've made the covalent bond though, which you've already been shown how to do in the last packet, you're going to add on to that what shape that molecule will have based on the bonds that it makes. And you're going to use this sheet from your reading material to figure that out. It's actually not that hard. The hardest part is making the covalent bonds, which you've already done. So let me show you how this works. I'm going to make BCl3. So I find on here boron, B, I know has 3 outer electrons because it's in group 13. So that number 3 there lets me know it has 3 outer electrons. So I know boron will have 3. Chlorine is in group 17. So it has 7 valence electrons. And so I will draw 7 dots around it. So remember when we did this in the last packet, you drew dots around one. So my boron, I can put dots around, and then you put X's around another. So chlorine, I could have 7 X's around. But here it shows me I'm going to use 3 chlorines. Well, I'm going to look at chlorine, and I need 1 more electron to give it that total of 8 that I need for it to be stable. And since I have 3 of them, and I know it's going to have to share with boron, look at this, it's got 1, 2, 3 places where it can share. So I'm going to put my boron here with its 1, 2, 3 outer electrons, and I'm going to put my chlorine on all 3 sides so it can share those. If boron is sharing 1 with this chlorine, then chlorine will share 1 back, so I put an X here. I need a total of 7 X's to show my 7 outer electrons. I've already drawn 1, so 2, 3, 4, 5, 6, 7. I'm going to do the same thing for this chlorine. Boron is sharing 1, so chlorine will share 1 back. 1, 2, 3, 4, 5, 6, 7. Again, chlorine will share 1 back with boron. 1, 2, 3, 4, 5, 6, 7. This is going to go against what we learned in the last packet, that everyone wants to have 8 outer electrons. When you get to the end here, each chlorine has 8. But boron, if you look around it, it only has 1, 2, 3, 4, 5, 6, even with the shared ones from the chlorine. This is okay for these molecules. Covalent bonds don't always end up with this center atom being a stable 8 like we've been talking about. And it's because these other atoms that are stable around it will keep the molecule stable. So don't worry about the middle atom. Worry that all of our outer atoms are stable. So we've made this bond. All of our chlorines are stable. Boron doesn't look stable, but the molecule will be. And then what I'm going to do is look at my middle atom and look at how many bonds it has. So boron is bonded to 1, 2, 3 different atoms. So I'm going to look at my Vsepr cheat sheet here, and what this shows me is the shape that a molecule will have after it has bonded in a covalent fashion. So if I had 2 bonds, then I would have a linear structure. 3 bonds is called a trigonal planar. 2 bonds and a lone pair, and we'll get to lone pairs in a moment. 2 bonds and a lone pair is going to be bent with 1 lone pair. 4 bonds, 1, 2, 3, 4, would be tetrahedral. 3 bonds and a lone pair is trigonal pyramid, and then bent has 2 bonds and 2 lone pairs. So remember, in this case, I had 1, 2, 3 bonds, so I find the one with 3 bonds, and it's trigonal planar. So I would label that here, trigonal planar. Now, if you have one that has lone pairs, it's going to look like what's in your reading material here. When you make water, H2O, and let me get a blank sheet here so I can draw it for you. You can see what it looks like if you're actually drawing it. H2O is going to have what are called lone pairs. So if I had hydrogen and oxygen, hydrogen has 1 valence electron, oxygen has 6. All right, and I know it's H2O, so I'm going to have 2 hydrogens bonded here. So since hydrogen needs 1 more because it can only hold 2, when I bond it with this, if it shares 1 with oxygen, oxygen will share 1 back. So I'm going to draw my oxygen with an X on one side for a hydrogen to bond with it here, and an X on the other side for another hydrogen to bond with it there. 1, 2, 3, 4, 5, 6 valence electrons for oxygen. Then hydrogen will share its 1, and the other hydrogen will share its 1, giving oxygen the 8 that it wants, and each hydrogen the 2 it wants. Now I look at the central atom again to decide the shape of the molecule. It has 2 bonds. It's bonded to this hydrogen, so I have 2 bonds. And then I have 2 pairs of electrons that aren't bonded with anything else. There's nothing here that these are bonded with, nothing here these are bonded with. These are called 2 lone pairs. This is a lone pair of electrons because it's not bonded to anything. So when I go to look at what shape water would have, I want to find 2 bonds and 2 lone pairs. So I go to 2 bonds, 2 X's, 2 lone pairs, 2 sets of dots, and I find that it's bent with 2 lone pairs. So I would label it as bent 2. And you don't have to write out the 2 lone pairs. The 2 is enough to know that it's bent with 2 lone pairs. So as you go through your worksheet, make all of your covalent bonds and then label what shape they will have. One little trick that's in the reading that a lot of people miss, it says any diatomic molecule, which is a 2-atom molecule, will have a linear structure. For example, if carbon and oxygen bond together to make carbon monoxide, since there's only 2 atoms there, they'll have to bond right next to each other. There's no other way for them to bond. They can't have any sort of special shape if there's only 2 atoms to bond with one another. They'll be next to each other, which is a linear shape. If you do still have any questions, please feel free to ask.